Okay, let's look at the homework 3.4, number 8. All right. So family has $115,898 30-year mortgage at 6.6% compounded monthly. All right. So let's answer the following questions. All right. So let's write down what we already know. So here, this guy right here is the present value. So present value is there. Right, so 30-year mortgage, all right? So we know that it's a 30-year mortgage. So this tells you that N is going to be 360 because it's a monthly payment. All right, then compounded monthly. So we know that I is going to be 0.066 divided by 12. Right, so this is going to be 0.0055. All right, so that's that. All right, so let's find the monthly payment. All right, so payment using the payment formula. So payment is going to be, all right, present value is 115,898. Right, then I is just 0.0055, right, divided by 1 minus 1.0055, raise it to the negative 360. Right, so let's get this value. Right, pull out the calculator. All right, so it's 115,898, right, multiplied by, right, 0.0055, right, divided by, right, quantity 1 minus 1.0055, raise it to the negative 360, right? Then close parentheses, right? So get that value, right? So the payment came out to be, right, $740.19, right? 19 cents. Right, so let's type it in. Right, so it's $740.19. All right, and let's check the answer. All right, got this one correctly. All right, total interest paid. All right, so let's try to find that. All right, so interest paid would be, we have, so each payment is $740.19, right? Then we multiply by, right, 360. So that will be a total payment. Then we want to subtract the amount that we borrowed, which is 115,898, right? So this comes out to be, right? So let's see, so 740.19, right, times 360, then subtract 115,898, right? So get that. Right, so it kind of came out to be 150,000 $570.40. right? So let's type it in. All right, so it's 150,570.40. Right? So let's check the answer. All right, so we got that. All right, time it takes to pay it all off if you decided to pay $100 more each month. Right? So let's do that. All right, so the new payment is going to be $100 more, so I'm going to add 100 to it. So that's going to be $840.19. Right? Then, so what we're going to do is we have to solve this equation. So present value is 115,898. Right? So this is equal to, right, payment is going to be 840.19, right, times, right, 1 minus 1.0055 raise it to the negative n, since we don't know n, over 0.0055. Right? So let's try to solve that. And first we're going to divide through by 840.19. So we're going to do it here. 840.19. Right? So that will cancel this guy. Right? Then multiply by 0.0055. Right? That will cancel this guy. Right? Then what you get is going to be, let's see, I'm going to put this term on the left hand side, so it's going to be 1.0055, right, is equal to, right, so I took care of this guy, and to the negative n power, so don't forget that. Right, so 1 is sitting on the right, so I'll leave that here. Right, this guy, I'm going to put it on the other side. So this is going to be, right, minus, right, 0.0055 times 115,898 divided by 840.19. All right. Then we can take the natural log of both sides. So I'm going to put the natural log here, and I'm going to put a natural log here, and put a big parentheses around here. All right. Then we can actually put negative n in front here. So I'm going to scratch that out and put the negative n. All right. Alright, so this will give us a way to solve for n. So n is going to be equal to, right, this expression right here. So natural log of 1 minus and 0.0055 times 115,898 divided by 840.19, right? Then divided by, right, negative natural log of 1.0055, right? So let's get this value, right? So we have natural log of 1 minus 0.0055 times 115,898, right, and then divided by 840.19, right? So we have that. then divided by, right, and negative natural log of 1.0055, right, and enter. Right, so this came out to be 259.19 and so on. All right, but we want number of years, so we have to divide this guy by 12. Right, so number of years will be 21.59, so 60. Right, so let's type it in. Right, number of years, 2 decimal places, so it's going to be 21.60 years. Right, so check the answer. Right, we got that. Right, then interest saved. All right, so let's do that. So this is going to be, right, interest saved would be, original payment would be, so that was 740, so 740.19, and you do that for 360 times, right? But with the new payment, all right, so with the new payment, you have 840.19, right? Then you do it for 259.19 times, right? So it's kind of a strange, but let's see. So let's get that value, right? So it's 740.19 times 360 minus 840.19 times 259.19. Right, so that came out to be, right, I'm going to go ahead and type it in. Right, this came out to be $48,699.55. All right, let's check the answer. All right, got that. All right, that's it. I hope that this was clear.